So at this point, you have completed the work and power Pulley Lab, and I'm hoping we can take a little look at the data you were able to acquire as part of that lab and the calculations that followed. So you have entered that into the form and the test that was available on Blackboard, but now that is going to give you a chance to really look at what kind of data we get and what can we make out of this data. So first off, we have all three of these different arrangements, 1, 2, and 3. Now, what you probably realized was that you would apply a much bigger force for arrangement 1 compared to being able to lift up the book just off the chair for arrangement 2, and then a much smaller force for arrangement 3. And the other thing you probably realized really quickly too as you were going through it is that as you did that, as you applied that really big force and you started pulling on it, you actually did not have to displace as much rope. So this is just a small amount of displacement for the first arrangement. And you can even see that from the diagram here. As you got this book up to here, you really only had to take that displaced rope and move it just a little bit, right? Just move it over about a couple meters. Arrangement 2 had a little bit bigger displacement, and arrangement 3 had a way bigger displacement. So that brings up the next piece. It'll be looking at your work values. So when you went through and you did your work calculations, you should have gotten work calculations that were pretty much the same. All of them. No matter how big of a force, no matter how much, how much more of a complex pulley system you had, the work was all the same. So that brings up the next point. Why? Why would the work be the same, even though it felt so different as you're bringing it up? And that goes down to the fact that we were doing the same thing. We were pulling that same book with the same mass up to the ceiling and back down. For our purposes, just up to the ceiling. And we did the same thing for all of them. We took that same book and we brought it up to the ceiling. We took the same book, brought it up to the ceiling. Our task was the same. So as a result, you should be actually seeing that the work is the same. So I always think of it like you were trying to accomplish the exact same thing, bringing the book up to the ceiling. And as a result, your work value should be the same for all of those. So we have this work component being the same. Now, let's talk also about this work. So we know the work was supposed to be the same. Now, what I want to do is take a look. What do we know about whether or not there was a positive or negative work? So let's look at our force and our displacement value. So I'm going to see if I can draw this on here a little bit. But if I'm over here and I'm pulling on my rope, and this is my hand here, there we go, and I'm pulling on that rope in which direction? Should be downward, right? So I'm applying a force in the downward direction. And then think, what direction was my displacement? In other words, what direction was my rope being moved? And the rope was actually being moved down also. So as you pull on the rope moved down, your force was in the same direction. So if I know that the force and the displacement were pointed in the same direction, we know that my work is going to be positive. So now let's see if we can start to look at what happened from a power standpoint. So power. For power, we know power is equal to work over time. So I knew, and I know from this, that my work stayed the same for each one. So let's see if we can start to look at if my work was the same. So let me erase some of this. Power equals work over time. For each of these, we said work stayed the same for all of them. So then the question is, what really will influence our power is the time piece. So let's go through and take another look at our data. From our data, you probably noticed and realized, even just not even looking at the data, just from your own experience, that it took a lot longer, way more time to be able to accomplish the movement of the book for arrangement 3. Arrangement 2 was a little bit smaller, and then arrangement 1 went really quickly. In other words, let's kind of draw this in on our little equation here and see if it can help to reinforce what's happening. So a really small time, a really medium-sized time, and a huge time. So if I take the same number for work and I divide it by a small number, it's going to give me a lot of work. So this is going to be a big amount of work. Okay, hold on one second. Ah. All right, so sorry about that. And as a result of this, we see that it's going to be a really, really big number. So let's try that again. Go back to it. Same work, really tiny number means a really big amount of power. And then as it goes down, it's a smaller amount of power, and then a really even tiny amount of power. So when you're looking at these numbers, this should be a really big power value, and then this should be a really tiny power value. So what does that mean? What does power really mean in this case? Power is all about how much energy you need to go and dissipate in a certain amount of time, how much work you're doing per second. So as a result of that, you're really looking at this power as being, I have to exert a lot of energy to be able to move this arrangement one up to the ceiling. In other words, it was a lot harder. And you probably felt that too. It was way harder. So I have way bigger power. Whereas over here in the third arrangement, it took a way bigger amount of time. So same work divided by a really big number means a really small power value. Small power value means I don't have to exert as much energy or do as much work per second. In other words, this is going to be a much easier task. So what we're seeing is that the more time it takes, the more complex our system is, the less work output that we need to do. And as a result, the easier it's going to be for us to accomplish the same task. The less work being done, less energy you need to exert. So as a result of this, we can actually see over here with a crane. So this is how it kind of applies in real life. When you have a crane, the whole idea of a crane is to make it easier for you to be able to go and move something up. So if you look at a crane, it actually is a really complex pulley system. A really complex pulley system means it's going to take a lot longer, which means that it's going to not have to exert as much energy and the power output is going to be much smaller. So you could take a big steel beam and you could just put it on your shoulder and just walk up 10 flights. But that would take a whole lot of power output. So by using a complex pulley system, you could actually instead take more time, bring it up, but allow it to accomplish the same amount of work, same task, but over more time, so there's less power output. In other words, less energy having to be exerted. Anyway, at this point, you should be able to now submit your work in Power Lab if it's complete. Submit that using the submission form. And then I want you to go, once you're done with that, study and get ready for a formative quiz. This will go in the gradebook. This is going to be the work and power piece here. So finish that formative quiz, and then you'll be able to move on to the next part. So take that formative quiz. You will not have retakes on this. So complete it, enter it, and do the best you can on that. And this is the point breakdown for that. All right. Hope you do well.